the constant multiplier rule tells us a few things that makes our lives a little bit easier. First of all, thinking about derivatives are defined as or are defined by limits. So the properties that apply to limits also apply to derivatives. So when we had a constant inside a limit, a constant multiplier inside a limit, we could pull it out in front. Well, that works the same for derivatives. So we have this constant multiplier in front of the function we want to take the derivative of. You can take that all the way out in front of the derivative. So in other words, some people also rewrite it as this, dx of c times f of x. You can do c times d dx of f of x, which then becomes c times f prime of x. So let's do the proof for it. We have take the derivative with respect to x of c times f of x, and we're going to use the limit definition for that. So the limit as delta x approaches 0, and I'm using delta x just to switch it up. No particular reason other than that. Then we have it's going to be c times f of x plus delta x minus c times f of x over delta x, like that. I could rewrite that in the numerator. We have c that can factor out. So delta x approaching 0, factor out the c, and we get f of x plus delta x minus f of x in the numerator all over delta x. And then that is a constant multiplier in a limit. We can pull that out, that we did the proof for that earlier when we did the properties of limits, or I showed you why that works. So I'm going to pull the c out. So then the limit of delta as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Well, that right here that I'm highlighting in yellow is the definition of the derivative. So that means I can rewrite that as c times f prime of x. That's the constant multiplier rule. So what does that mean in terms of our problems? Well, that for us, it means this, essentially. We can do problems like in example 5. We want to find y prime. That means I can essentially do 4 times d dx of just x to the 4th, like that. So that is going to give me, y prime is equal to 4 times the derivative of x to the 4th. We just used to prove the power rule is 4x to the 3rd. So that's going to give me 16x to the 3rd. I'm fine with that. Like, you don't have to write the rewrite for this. Normally, you wouldn't rewrite that. Normally, you would look at this and say, okay, we take the coefficient times the exponent. That's going to be the leading coefficient of our derivative, and then you reduce the power by 1. But if you have something like the second problem here, it does help you to rewrite this. So it's going to be y is equal to 5 over 3 x to the negative 1st. And then you're going to use the power rule. Y prime is equal to, or maybe, you know what, we're going to write dy dx just to change the dy dx is equal to 5 times 3, and then the derivative of x to the negative 1 using the power rule is going to be negative 1 x to the negative 2nd power. So then I'm going to polish that off a little bit and write negative 5/3 x to the negative 2. Now, if it doesn't specify, you don't have to simplify. You could leave it like this, or you could write it as negative 5/3 x to the 2nd power in the denominator. Ooh, I forgot the y. dy dx here. Or dy dx is equal to, like that. All right, try the next ones. You're going to rewrite, for example, f of t just be careful. It's the letter T now we're talking. And you're going to write it as 2/7 T to the 4th. And then use the power rule. Pause the video and try these, and then come back and check if you did them right. F prime of T here. I think I'll write dy dx. And that's it. Now notice some of the or statements, you could also have taken out an x, you could have simplified some of those, you could have rationalized. Unnecessary and not needed. You don't have to do that. All right. Now try these and see. It's called the multiple rule and the power rule. If we put the multiple rule and power rule together, I kind of talked about it already, but try these here and come up with a rule. And we'll come back and do some more in the next video.